Okay, this is chapter 5.1, graphing quadratic functions when b equals 0. We're going to start by reminding you of what the parent quadratic function entails, and that's a really basic function. In fact, it's the simplest quadratic function, but it can be very powerful in helping you understand other quadratics. So the parent function is y equals x squared, and there's a 1 here even though it's not written, so a is 1 because the standard form of the quadratic equation is ax squared. There's where your 1 is, the a part, plus bx. Well, b is 0, because that's why there is no b. And then plus c, there's no c either, so that's 0. So if we were to just set up a table of values where this y equals x squared, and we chose a nice easy point, 0 is always a nice one to choose. We put it in here, so y equals 0 squared. Then y would equal 0. So the ordered pair would be 0, 0, which is in fact the vertex. Now we'll put in 1. So y equals 1 squared, and that's going to be 1. So the ordered pair is 1, 1. And then we'll go ahead and put in 2, because we're just going to the right of this vertex. We know that that's the vertex. And it's going to be y equals, substitute the x with 2 squared. So y equals 4. And so the ordered pair is 2, 4. Plot it. 2, 4. We're going to go ahead and draw the right side of our parabola. We're going to put in the axis of symmetry. The axis of symmetry is an imaginary line that separates the parabola into two equal or congruent parts. It is a vertical line. It crosses the x-axis, so it's called x equals, this is its equation. The point where it crosses is 0, so x equals 0 is this equation. Now we're going to go ahead and reflect each of these points. So this is 1, 1. Let's go ahead and write those points. 1, 1, 0, 0. 2, 4. So now we're going to reflect and plot that point. And that's going to be negative 1, 1. And then we're going to, this is 2, 4 is 2 to the right of the axis of symmetry. We're going to go 2 to the left. And that point's going to be negative 2, 4. Then we're going to connect these points. And your parabola is complete. The pattern here, let's get a different color, is that we go back to the vertex. So when you have an A that's 1, the pattern will always follow this, 1 or negative 1. The pattern will be that you go 1 to the right from the vertex and 1 up and plot a point. You go 1 back to the left from the vertex and go 1 up and plot a point. Now if it were a negative x squared, you just go down instead of going up. Go back to the vertex, then you're going to go 2 to the right, 1, let's get a different color even for this one, 2. 1, 2, and then we're going to, that wasn't a different color. 1, 2, and then we would go up 1, 2, 3, 4, and then go back to the vertex, go to the left side 2, and then go up 1, 2, 3, 4. You can see how you could plot your points without ever having done any mathematics. This only works when the A is 1 or negative 1. So we'll talk about that in the next one. Okay, so here's our first example. Y equals negative x squared plus 3. So A, remember this is the standard form, ax squared of the quadratic function plus bx plus c. Y equals. So that should be something you can look back at. So we have negative 1 for our A. Our b is not there. Bx is not there, so it's 0. And c is 3. It's going to open up, or open down, excuse me, because the A value is negative. And its vertex, when B is 0, the vertex will always be the C value. So the vertex is going to be 0, 3, because it's always going to be the C value. Let's plot that. Label it. It's going to open down, so I'm going to put my label above it. Now, we will use the pattern that I worked with the parent function, but let's just do a table of values so you can see that it both ways work. So we're going to go x. We know that we have an axis of symmetry. We know that it's going to pass through the vertex. Let's take care of that first. our axis of symmetry crosses the x-axis at 0, so it's x equals 0. That's the equation. Now we're going to have a table of values, x, y, and work. Now, we are going to pick something to the right, so let's pick 1. Let's make it easy. So we're going to have y equals negative 1. That's what that is, negative 1. And then x is 1 squared plus 3. So y equals 1 squared is 1 times negative 1 is negative 1 plus 3. And negative 1 and 3 is 2, so y equals 2. So 1, 2. It's the ordered pair. 1, 2. Now we're going to go ahead and reflect, because one of your steps is to reflect, so we'll change the color. The 1, 2 is, let's go back, write that. 1, 2 is 1 to the right of the axis of symmetry, so we'll go back to the left, 1, plot a point, and that's going to be negative 1, 2. And there's that side, and here's this side. Remember, they're U-shaped, not V-shaped. Okay, now we'll pick 2, plugging it into that form, into that quadratic equation. Y equals negative 1. That's what the negative right here is, negative 1. The x value is 2, square it, plus 3. So y equals 2 squared is 4, times negative 1 is negative 4, plus 3. Y equals negative 1. So your ordered pair is 2, negative 1. So 2, negative 1, labeling it. Always want to label your ordered pairs, connect through, arrow on the end, and then we're going to reflect it. This point is 2 from the axis of symmetry on the right, so go 2 to the left, plot a point. That's going to be negative 2, negative 1. Connect through the point and draw your arrow. There's your parabola. Okay, now let's show how you would have done this. Let's show how you would have done this with just the parent function idea. So let's use a different color. So parent function would say go to the vertex, go 1 to the right, 1 down. Oh, you hit the point, 1, 2. Go back to the vertex, 1 to the left, 1 down. You hit the point, negative 1, 2. You can get 2 more points by going back to the vertex, going over 1, 2, and then down 4. 1, 2, 3, 4. You hit the point, 2, negative 1. Go back to the vertex, 1, 2, down 1, 2, 3, 4. You hit the point, negative 2, negative 1. So without doing any of this table work, you would be able to graph this particular quadratic equation. Now, this method that I showed you in the orange only works when the absolute value of A equals 1. So negative 1 is the A. The absolute value of that is 1. When that's true, it's the parabola. So when A equals 1, the parabola is the same size and shape as the parent function. All right, let's go to letter B, second one. Y equals 2x squared minus 1. Now this one you can't use the pattern on. You actually have to have a table of values. Once you go ahead and pause the video, try to do as much of it as you can, and then I'll turn it back on, and then I'll talk to you a little bit about it. One thing you will notice is it's narrower, and I'll talk to you about why it's narrower than the parent function. Okay, in letter B, y equals 2x squared minus 1. A was 2. B again is 0. C is negative 1. And when B is 0, the vertex is going to be the C value, 0, negative 1. It's plotted here. We know the parabola opens up because 2 is a positive number. We chose, from 0, negative 1, we chose 1 and 2 as our x values. When we plugged in 1, we ended up with y equals 2 times 1 squared minus 1, which is 2 minus 1, which is 1. 1, 1 is plotted, then reflected over the axis of symmetry for negative 1, 1. 2 is substituted in, y equals 2 times, in parentheses, 2 squared minus 1. 2 squared is 4, times 2 is 8, 8 minus 1 is 7. So the ordered pair is 2, 7. That one is also, that point 2, 7 is also 2 from the axis of symmetry on the right, so we go 2 to the left of the axis of symmetry and get negative 2, 7 in our reflection. You can see that this is a thinner parabola. That's because anytime a is greater than 1, absolute value of a, so it could be 2, negative 2, 3, negative 3, is greater than 1, the parabola will be narrower than the parent function. Not really that useful, but kind of nice to know so that you know what you're looking for. Okay, now we're moving on to where you have y equals negative 1/3 x squared plus 5. And what's different here is that your a value is a fraction. So negative 1/3 is your a, your b is still 0, and your c is 5. The vertex is going to be 0, 5. We're going to plot it. And it's going to open down because it's a negative a. So we're going to put our ordered pair up here, 0, 5. And then we're going to do a table of values. Okay, for your table of values, we're going to use 1. So we just go ahead and we're not going to use 1 as we normally would. What we're going to do is pick a number that will be divisible, that 3 will divide into, because taking 1/3 of something is like dividing by 3. So if we were to square 1 squared, we'd get 1. That doesn't help. 2 squared is 4. We'd still end up with a fraction when we multiplied it. But if we go 3 squared, so we'll choose 3, it's negative y equals negative 1/3 times 3 squared plus 5. 3 squared is 9, so it's y equals negative 1/3 times 9 plus 5. Now, when you take a third of something, it's like dividing by 3. A fourth of something is like dividing by 4. A seventh of something is like dividing by 7. So 9 divided by 3 is 3. Negative times a positive is a negative. So y equals negative 3 plus 5. Y equals 2. So your ordered pair is 3, 2. We're going to plot that. 3, 2. You're going to see that it's going to be much wider. And we're going to label it. Then we are going to reflect it over the axis of symmetry. There's 3. Here's your axis of symmetry. Let's get that drawn in. Your axis of symmetry goes through the vertex. It's that imaginary line that splits the parabola into 2 equal parts. It crosses the x-axis at 0, so x equals 0 is the equation. And then we're going to reflect that 3, 2, 3 to the left of the axis of symmetry, which gives us negative 3, 2. And then we'll go ahead and connect this way, and we're going to go ahead and connect this way. Okay, now we're going to choose another point. Again, we're not going to choose 4 for our x because that wouldn't, 4 squared is 16. 16 isn't evenly divisible by 3. 5 squared would give us 25, also not evenly divisible by 3, but 6 squared gives us, 6 squared would give us 36, so that's divisible by 3. So y equals negative 1/3. X is going to be substituted with the 6 squared plus 5. Y equals negative 1/3 times 36 plus 5. Multiplying by 1/3 is the same as dividing by 3, so y equals, negative times a positive is a negative, negative 12 plus 5. And y equals negative 7. So 6, negative 7 is our ordered pair. Okay, we're going to graph that. So 6, negative 7. And then we'll connect through that. And then we go to the, we're going to reflect it. 1, 2, 3, 4, 5, 6. We'll go 6 the other way. 1, 2, 3, 4, 5, 6 to the left. Plot a point. And that should be negative 6, negative 7, which it is. Negative 6, negative 7. I have to do D&E on another slide, so check out the other video.